Dear students, welcome to the virtual learning platform of Shri Guru Sudhindra College. So on screen you have the discrete mathematics program number 6, program to implement the universal quantification. So in this program you are going to uh, learn about the universal quantification concepts. So what is this, right? So the concept is a very large thing, right? It's something bigger concept which needs a core mathematical ideas. But here I'm simplifying it with specification specific to one single example, right? It is not a generalized program. This program we have made it very customized and specific to a special what you call a given equation, right? In mathematical terms it is limited to a given equation. Let me run and show you how the output you'll get, then you'll understand it better. Okay, see here on screen you have the output n is equals to 1 true, n equals to 2 true, then similarly 3, 4, 5, 6, 7, 8, 9, 10, up to 10 it is true. Now why it is displaying the output in this way, right? Now what is happening here? So some values are repeating again and again and again. It means in our program we are using a loop, isn't it? N value is changing. It means the value is changing and this is the core part. Now what is happening here? On screen you have the program n, right? So there's a variable n, so let me declare the variable n here. Then a for loop is taken for n is equals to 1. Okay, see here n is equals to 1 starting, the last value is 10, right? But here in this equation we are not going to mention it as 10, right? Directly I'll take n is equals to 1, the initialization, n plus plus for every what you call phase we need to increase it by 1. But here there is a specific condition, n plus 4 greater than 3, right? So we are considering a equation here, n plus 4 greater than 3. Initialized value is initialized, then we are checking the condition. If this particular condition is true, then we are going to enter here, then the process happens. Now here what is happening? Printf n is equals to percent d true n, right? See, n is equals to percent d true n. So what is n here? N is nothing but 1. Initially it is 1. During second iteration it's going to 2, then 3, 4, 5, 6, up to 100,000 it works. But for every loop condition there must be an exit statement, right? So the exit statement is this: if n is equals to 10, I have written a statement break. So if you want to exit it for 5, right? So let me take it for 5. If n is equals to 5, then break. Once again let me run. Okay, I got the value here 1, 2, 3, 4, 5, because this is my exit statement. So through this particular program here you are understanding, right, a concept on using even the for loop. There is a possibility to have a control here inside, isn't it? Normally what happens is for loop is considered as a fixed loop, because we are going to mention the initial statement, then the update counter, and along with that the condition. But here what we are doing is the initialization is there, update counter is there, then along with that there is a condition mentioned. But here there is a specifically the exit condition is mentioned here. N is equals to 1, then the condition is here equation, then this particular value initialized, checked the condition, then the updated the counter, then post that this particular thing. If n is equals to 5, then we need to break, otherwise we need to continue. So this is the program to implement universal quantification. So the program is very small here, only one loop you need to take. There are multiple ways to design this, right? So there's no specification here. However you want, you can design the program here, but for this case this concept is used here. N is equals to 1 is the initialize statement, n plus plus we are going to increase the value, and here there's a condition which we are going to mention, right? Now once the values are mentioned, once the condition is set, what we are going to do is we are going to check the value here. If n value, in case if n value is equals to 5, then we are going to break, otherwise it's going to continue. So this is the program to implement universal quantification. Go through the program, try the program, give different values for n here, and check, right? So you may get, you surely you are going to get the different kind of outputs. Understand it. If there are any kind of difficulties, please feel free to approach. Happy programming. Thank you.